This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs. Also, make sure to check out and subscribe to our YouTube original channel, UCTV Prime, available only on YouTube.
Funding for this program was provided by the UCLA Office of Instructional Development.
Good afternoon. I'm a bit humbled by all of that. I am very honored to have been chosen to give this lecture. And I would like to thank Associate Dean Ren Sun from the School of Medicine and Dean Linda Rosenstock from the School of Public Health, but most especially my close colleague and publicity manager, Zhofeng Zhang, for nominating me for this honor. And I will try to make this lecture as interesting as possible. Now, as you've heard, this is the first time that someone from public health has been nominated. It's also the first time that somebody from epidemiology has been so honored. And so, realizing that I had a captive audience, I decided to tell you first, what is public health? So public health is the science and art of preventing disease, prolonging life, and promoting health through the organized efforts of society. Our own Dean Breslow defined it as the process of mobilizing local, state, provincial, national, and international resources to assure the conditions in which all people can be healthy. Professor Jonathan Fielding, after whom the School of Public Health is named, pointed out that the three major tasks of public health are to protect the health of the public, to prevent disease and factors which compromise the public's health and function, and to promote the health of the public. An illustrious graduate of the School of Public Health, David Satcher, who subsequently became the Surgeon General of the United States, stated that the fundamental maxim of public health is that the health of the individual is best ensured by maintaining and improving the health of the community. Then Deedles came along and defined the goal of public health as the biologic, physical, and mental well-being of all members of the global society, regardless of ethnicity, religion, gender, sexual orientation, country, or even political views. So now I'd like to turn to a brief discussion of what is epidemiology. I often tell my students that it actually comes from the Greek, epidemos and logos, which is, logos is the study, epi is upon, and demos is people. But one of my students pointed out to me that demos is not as close to demiology as demios is, which of course means executioner. Epidemiology is a strategy for the study of factors relating to the etiology, prevention, and control of disease to promote health and to efficiently allocate efforts and resources for health promotion, maintenance, and medical care in human populations. Now, I like to tell my students that epidemiology is actually a religion. And the Christian religion, which is my background, has one Holy Trinity, the Father, Son, and Holy Ghost, but epidemiology tries to go that one better. So we have two Holy Trinities of epidemiology. And the first is the idea that health is a state of equilibrium between the agent, the host, which is usually the human, and the environment. And if you mess with any one of that trinity, disease will result. Now, the second Holy Trinity is the trinity that we use to describe the relationship between agent, host, and environment. And that's time, place, and person. Now, after that brief description, I'd like to talk to you about the road to resistance. I will start by telling you a little bit about the multi-center AIDS cohort from which my remarks have been drawn. The Vice Chancellor has given you some description of it, but let me continue. We started the cohort studies at UCLA in 1981, at which time Professor John Fahey very generously allocated to me $3,000 and agreed to run the flow cytology for me on a study of students at UCLA. The organization was known as the Gay and Lesbian Association, or GALA. In 1983, the National Institutes of Health decided to provide funding for research on HIV and established funding that was given to 4 different institutions: Johns Hopkins, Northwestern, Pittsburgh, and UCLA. So I called up the PIs, principal investigators at the other institutions, and said, hey, why don't we collaborate? Because I think together we can do more than if we try to do something individually. So we joined forces and recruited 5,622 men who have sex with men. At the baseline, in 1983-84, 39% of the men, unfortunately, had already been infected. And subsequently, over 600 of them have seroconverted and become infected. We follow these men every 6 months by asking them a series of exceedingly embarrassing questions and also collect biologic specimens. I once had one of the participants present to my students as to what it felt like to be a participant in this study. And at the conclusion of his remarks, one of the students raised her hand and said, what do you find is the most difficult part of participating in the multi-center AIDS cohort? And he responded, well, you know, they asked me what I did, with whom I did it, how many times I did it, and the interviewer looks like my grandmother. One of the great things that we did, and it's always wonderful to be able to look back and realize that you did something right at the beginning. And what we did right was we established both national and local repositories of biologic specimens. At each of the 6-month visits, we took an extensive questionnaire on various medical history, health services, behavior, medications, and so forth, and we took specimens. We were very fortunate that at the very beginning, we set up laboratories at each of the centers. And this has been one of the great strengths of the MACs. And it was Professor John Fahey who saw to it that the laboratory at UCLA was the best. Now, this schematic drawing, I'll just run through very, very quickly. It's to show you the cohort. At the beginning, we had some people who were already infected, some who were not. Some of the ones who were not infected became infected. Now, this group was particularly interesting because we had the entire natural history from before they were infected to the point where they became infected on through the entire course of disease. And so this was a particularly unique population. Now, as the Vice Chancellor has said, we have, as a group, published somewhat over 11,000 publications in various medical journals. We have expanded the cohort and now have close to 7,000 participants and almost 90,000 person years of follow-up, 12,000 different variables, and over 1.5 million different biologic specimens. So this is indeed a unique resource. Now, it became apparent after we had gotten the study going for some time that there were some groups within the cohort who were particularly interesting. There are the long-term survivors who were infected, and they knew how to cope with the virus. So we needed to learn from them how to do it. We realized that there were people who had a very severely compromised immune system, but they continued to survive. And we looked intensively at that group here at UCLA. As I commented, we look at the individuals who seroconverted because we knew what their immunologic condition was before infection, during infection, and through the entire course of disease. But of particular interest to me was the high-risk seronegatives. They knew how not to get infected. That's something we needed to know. And so my talk today will concentrate on that group. And we needed to know what was the response to treatment of the individuals who were infected. And we realized, with the help of Professor Rita Efros here at UCLA, that aging was occurring faster in the AIDS-affected population despite treatment. And so we have focused on that group. Now, in 1985, it became possible to isolate the virus. And so the MACs decided that we would get involved in the process of trying to isolate the virus. The other three centers decided they would try to isolate the virus from the individuals who were known to be infected, antibody positive. However, my feeling was that that really wasn't useful because we already knew that they were infected. What we really wanted to know was what was happening to the men and their immune system as they became infected. So we decided that we would not make isolation attempts from infected men, but from men who we expected to become infected. So we picked a population of men who had exceedingly many partners, and thus were very likely to be exposed to HIV while we had them under observation. And indeed, we found 31 men who were antibody negative and isolation positive. That is to say, the usual test said they were not infected, but we isolated virus. Now, this is a very disturbing finding. And so my colleagues and I were confronted with a difficult decision. because the antibody test was the test that was used to protect the blood supply. Thus, if people were infected, but they were test negative, that meant testing the blood supply might not protect the individuals from getting a contaminated unit of blood. So I conferred with my colleagues, and we decided that we would need a second independent indicator of the fact that these men were indeed infected. In the meantime, Professor Ranke from Finland published a paper in which he studied 14 antibody-negative partners of individuals who were infected. And he found that 5 of the 14 responded to one of the proteins of the virus, suggesting that some epitopes of the HIV envelope are immunogenic, that is, capable of eliciting an immune response, and may reflect prior exposure to HIV. We then continued our studies. Dr. Imagawa was the virologist with whom I worked, an absolutely meticulous laboratorian, and one of the finest men that I've had the honor to work with. And so we tried to isolate from 133 men. 31 of them were antibody negative, but we isolated virus from them. 4 of them subsequently seroconverted, but the other 27 did not. By that time, a new test of the virus had developed, a polymerase chain reaction, or PCR. And so we took specimens from these men that had never been in Dr. Imagawa's laboratory and sent them to the scientist who had invented PCR and asked him to run the specimens blindly. We also gave him some from whom we had not made isolations. And he confirmed those isolations and confirmed that they were infected. So now we're confronted with a very serious dilemma. Now, I would like to point out that we looked very hard at what circumstances surrounded the procedures for isolation. The usual procedure was to take cells from the individual that we wanted to test and mix them with cells that had been activated to make them susceptible to HIV infection. However, Dr. Imagawa decided that it probably would be more efficient to, in fact, activate the cells from the person being tested as well. And that probably was absolutely key in affording us the opportunity to make the isolations. So we realized that the cells needed to be activated to successfully complete the process of infection. Now, we were confronted with a very serious ethical problem. Here we have evidence that some people are infected with the virus, but the test is negative. Now, we also realized that if we published this paper, we were going to create tremendous anxiety in the public at large and in the scientific community. So the ethical dilemma became, do we publish this finding and confront the anxiety, or do we not publish? And in that case, this information would not be available to the scientific community. I made the decision that the scientific community, in fact, had to know that there was a possibility that people who were test negative were harboring virus, so we published. And that's the paper there is. The result was that the Centers for Disease Control suddenly got hundreds of calls saying, is the blood supply safe? And so they realized that they had to do something to challenge the paper. Now, the appropriate place to do that is in the New England Journal, which is where we published the paper. And I assure you, we got many letters from scientists questioning what we did, and that is absolutely appropriate. However, I discovered later that the Centers for Disease Control called up my classmate, Lawrence Altman, although I didn't realize at the time he was my classmate, and basically said to him, we've got to discredit Deedles. There are too many bad outcomes of this paper, and so they made it clear that he was going to have trouble getting more scoops from CDC if he didn't deep six our article. So he called me and talked to me for an hour, and then he wrote this article. Absolutely none of what I said was quoted in the article. The article indicated that we were unethical and incompetent, and that Dr. Imagawa was a hack. Dr. Imagawa had a heart attack and died 2 days after this paper. I was so mad that I wrote a letter to Altman, and I said, you bastard, you're a killer. I still feel very strongly about that, as you can tell. Now, instead of folding up our tent and disappearing, we persisted. And we did a study of what happened after we made the initial isolations. And what we found was in 1986, it became apparent how HIV was being transmitted in the MSM population. And so the gay men dramatically changed their behavior. And what we found was of the 26 men from whom we'd isolated virus in 1985-86 changed their behavior. And so they no longer had exposure to HIV. We continued to make isolation attempts from them, but were not able to make any. On the other hand, one of the 27 men continued his high-risk activities, and we continued to make further isolations from him. So we realized that the men were transiently infected, but apparently were able to clear HIV from their bodies. Now that is an exciting hypothesis, because if these men can do that, we have to know how they do it. If we can learn how they do it, then perhaps we can confer that mechanism that they have naturally on individuals who don't have it naturally, and provide those individuals with protection from infection. Okay. Now, I subsequently did a study with my colleagues, particularly with Professor Janice Georgi, a brilliant immunologist with whom I spent many an hour screaming at each other over science. It was exceedingly exciting. And Janice was just a unique person. Unfortunately, She died in her early 50s, but I want to acknowledge that she played a very significant role in this study. After the article in the New York Times, we were not able to publish any further studies on these 27 men. We had been effectively blackballed. And so I tried another little trick. I defined 250 of the men from the MACs who continued to have many, many partners and included as a control group MSM, who had very few partners but were seronegative. I couldn't take a historical control because the assays that we were doing required fresh cells. And what we found was that the men who were resistant to HIV infection had increased levels of neutrophils and of CD8 cells. And that's particularly interesting because the CD8 cells are the principal cell of the immune system that responds to HIV. And so our interpretation was that CD8 cells may modulate outcome of HIV exposure. Very shortly thereafter, Professor Yvonne Bryson of UCLA as well did a study on infants, and she did viral cultures on infants who were antibody positive and found that some of them were infected 19 days after birth, but by 12 months had in fact cleared their virus. So the interpretation was that these infants had also successfully cleared HIV and reinforced the findings that we had. I then joined forces with some immunologists geneticists from the National Cancer Institute, specifically Dean Mann and Mary Carrington, and a number of my students. And we did genetic and immunologic studies of these resistant men. We compared 13 of the resistant men with 27 seroconverters. But we took the specimens from the seroconverters prior to the time that they became infected. So we considered them to be particularly vulnerable to HIV. And we found that the median percentage of activated CD8 cells was higher in the resistant men. We also looked at these men and did genetic studies, and we found significantly higher levels of one HLA subtype and of the TAP 1.4 and 2.3 genes. So our interpretation was the genetic factors which are involved in the transport of viral particles or subunits to cells are associated with resistance to infection. So let me just tell you what that is all about for those of you who are not immunologists. The virus comes along and it enters a particular type of cell that belongs to what we call the innate immune system. Within that cell, the virus is broken down into peptides or epitopes, which are then taken to the surface of the cell, and they're displayed on the surface of the cell. And what they do is that they say to the CD8 cells, "Hey, beautiful, come over here, I got something for you." What they have for them is a signal that says, if you see any cells with this particular epitope on them, kill them. And so we hypothesized in 1995 that HIV-resistant MSM have genetically mediated more efficient MHC transport and presentation of the HIV epitopes, resulting in sufficient levels of CD8 cytotoxic cells to clear low levels of HIV-infected cells. And the publication of that paper and the hypothesis was greeted with overwhelming yawns. However, science marched on despite my persisting anonymity. And John Brown, who's also a professor here at UCLA, and I did a study in which we looked at the low-risk people who'd converted, the low-risk seronegatives, and the high-risk seronegatives. That should be seronegatives. I'm sorry, in 16 resistant individuals. And Dr. Brown found higher levels of super antigen binding serum antibodies to a component of the virus, GP120, which again said that these individuals had obviously had previous exposure to HIV, and they stimulated antibodies which were not the usual antibodies. Then we joined with other investigators and had a particularly significant finding. But let me explain, first of all. This is the virus, and the virus has sticking out from its surface a glycoprotein 120 and a 41. And the glycoprotein 120 attaches to receptors on the target cell, which is a CD4 cell. And one receptor is a CD4 receptor, and the other receptor is a CCR5 receptor. These receptors are used by the immune system, which has various types of cells which need to communicate with each other. And they communicate with each other by releasing a chemical, which is then picked up by these receptors. But the virus GP120 is able to mimic those. And that's the way that they attach to the target cell. Now, our colleagues took the men that we defined as resistant men and seropositives and looked at the presence, or looked for the presence of the CCR5 receptor. And what they found was that fewer than 5% of the resistant men, but 5% of the resistant men, in fact, were lacking that CCR5 receptor. And so that meant the virus could not attach to the cell and infect the target cell of the host. So he also tried to find homozygous or individuals who were lacking the CCR5 among people who were infected and found none. So the interpretation was that 100% of individuals who lack the CCR5 receptor are not infected, that the absence of the CCR5 receptor actually protects the individual. Now, about this time, Frank Plummer and one of the graduates of our program in epidemiology did a study of sex workers in the Pumwani district of Nairobi. And they looked at 25 new sex workers and 32 sex workers who were not, had no antibody, and low-risk housewives. And what they found was that over half of the resistant sex workers had specific CD8 responses to the virus, as we had observed earlier. Okay, and 20% of the sex workers who had only been working for a matter of months had these specific CD8 responses, and none of the housewives did. The interpretation was the resistant CSWs had CTL CD8 cells that cleared HIV. Dr. Roland Jones from the United Kingdom did another study of sex workers in which he looked at 21 apparently HIV-resistant sex workers and compared them to lab workers at Oxford University who had the same genetic distribution of alleles for the MHC. And what she found was that a little under half of the CSWs that were resistant had CD8 cells that responded to the HIV peptides, and found that in 7 of 10 to specific subtypes of the HIV. But none of the lab workers had those CTL or CD8 cell responses. The interpretation, again, was that the resistant sex workers had broadly reactive, effective CTL, CD8 cells, but mainly to the conserved regions of HIV. Now, the study was also done in 2002 of 18 resistant injection drug users. So now we've moved into a different population that is infected not through sex, but through injection drug use. And they basically found the same thing. 12 of the 18 resistant IDUs had MHC that stimulated the more effective CD8 response, and that was not found in any of the seroconverters. So the resistance, the interpretation was that resistant men have specific responses to HIV that are stimulated by the process of presenting the antigens, in the antigen presenting process that I described earlier. Now, studies then were done subsequently in 2011 and identified a subset of the innate immune system, which suggested that these subset of cells, the KIR3DL1 NK cells, natural killer cells, which had a specific HLA subtype, were more able to more efficiently eliminate HIV. So the interpretation was a particular genetically determined subset of these cells eliminate HIV through their interaction with the CD8 cells. And a subsequent study, another study found the same thing. Now, you'll notice that it says HESN. I prefer to refer to these men as resistant, or these individuals as resistant, but the jargon adopted by the National Institutes of Health is highly exposed seronegatives. And that's the term that is now used, and you'll see it. Another investigator also looked at one of the major antigen-presenting cells and noted that in the resistant men, there was greater proliferation of these cells and maturation, and that they responded more vigorously to HIV, thus presumably providing more signal to the CD8 cells to go find the cells with those epitopes and to kill them. Okay, I think this is a little bit too technical. Just earlier this year, Professor Gardiali did a study which suggested that the interaction of these innate immune cells, the NK cells, and the dendritic cells, which are the antigen-presenting cells I described earlier, produce more of a cytokine that is involved in stimulating the CD8 cells. Okay, this says basically the same thing. So there have been a number of studies that have identified individuals who are resistant to infection. Beginning with the study that my colleagues and I did among MSM back in 1985-86, followed by the observations we made in 1989, and then the observations that, in fact, some commercial sex workers did not become infected despite repeated infection to HIV. And this was also confirmed in health workers and in injection drug users and in hemophiliacs. So the major groups which were infected through different routes all demonstrated this resistance. So in conclusion, what do we know? We know that there are factors that are associated with resistance to infection. I believe that there are probably multiple factors that confer resistance to individuals that protects them from HIV infection. One of them we know for sure is the absence of the CCR5 receptor so that the virus cannot attach to the target cell. We know that there is more vigorous dendritic cell proliferation and maturation. And the dendritic cell are the cells that present these epitopes of the HIV on the surface and say to the CD8 cells, come on, honey, I've got something special for you. There are probably other mechanisms as well. You may wonder at the title of this paper, it's interesting that now in 2012, there is universal acceptance that some individuals are resistant to HIV infection, and that in fact the antigen-presenting cells are in fact key in this as one mechanism of infection and work through stimulating the CD8 cells so that they can eliminate low doses of HIV, remarkably similar to the hypothesis that was offered in 1992. I think this is important because we have been tweaking the virus since 1985, so that's well over 20 years. And we have not come up with an effective vaccine using the traditional mechanisms of developing a vaccine. Therefore, I think we need to learn from these resistant individuals how they protect themselves from infection so that we can confer that protection on individuals who do not naturally have that mechanism to protect them from HIV infection. So there's a moral. The moral is hang in and have smart friends. And I'm a stubborn cuss who has had the good fortune to have many, many smart friends. But there are a number of them that I would like to particularly thank. First of all, Professor Michael Gottlieb. AIDS is a UCLA disease. Professor Gottlieb was the first individual to recognize that AIDS was a unique syndrome and represented a new disease that had never been reported before. I was very excited about his publication. Just about the time it was published, he called me up and said, "Roger, would you like to study this?" And I said, "You bet I would." I'd like to thank John Fahey. The Los Angeles Max would never have gotten started if John had not given me $3,000 and lab support, and if he had not established the basic laboratory procedures and quality control procedures that have become standard in the Max. I, of course, would like to thank David Imagawa, without whom none of this would have been possible, as is true for Janice Georgie. Barbara Vischer worked with me from the very beginning, and Barbara was very useful because when I presented my harebrained theories, Barbara was the first one to attack them. And if I could survive her attacks, then I felt a great deal more confidence. Otanio Martinez Mata has been a valued colleague, and his immunologic expertise, but even more his sound judgment and counsel have been very deeply appreciated. I'd also like to thank Mimi Dietels, who for over 49 years has provided me with art, beauty, and color-coordinated attire. Most of all, I would like to thank the men and the staff of the Max. The men of the Max come in every 6 months, and every 6 months we ask them all these questions about what they do. We are reminding them how vulnerable they are, and we are reminding the ones who continue to engage in high-risk activities that they shouldn't be doing it, but they do it. And yet, these men come in time after time. We test them to see if they're losing their ability to think. That's one of the outcomes of HIV infection. And we give them tests every time they come in. They can tell when they're beginning to fail those tests, and yet they come in again and again and again. So it is impossible for me to overemphasize how important the contribution of these men have been. And I'd like to thank my staff. My staff are extraordinary. Some of them have been with me for 25 or more years. Almost all of them have been with me for at least 10 years. And it's not easy working on the Max, because when you see these men again and again over the course of 25 or 30 years, you form friendships with them. And you have to watch these guys do things that are going to cause them to get infected. And until 1995, you had to watch these men get infected and die a horrible death. And it takes unbelievable courage for the staff to continue to work under those conditions. And they have been just an extraordinary group to work with, and one of the most rewarding things about these last 30 years. And finally, I would like to thank UCLA, which has afforded me the opportunity to do this research and research in many other areas, and has provided me with the great benefit of having access to leaders in the other scientific fields, including immunology, virology, behavioral sciences, etc., all of which were essential to the success of the multi-center AIDS cohort. So thank you very much for this opportunity, and thank you for your patience in listening to me rant on. Thank you.
No, don't go away. Come on back. What a great job. I mean, he just told the story of his science and the story of his scientists. It's really exactly what we would have hoped for. I hope the lights will go up now, though, because we do have some opportunities for questions, and there's so many smart friends in the audience. I'm sure you want to toss them a few softballs here. This is your chance.
Well, the reason I have smart friends is because they're going to answer the tough questions.
Right next. Oh, right here first, yes. Should be some perks of sitting in the second row.
In the introduction, you talked a little bit about the Fogarty program, which is a training program that brings people from various developing countries to UCLA and getting a master's or a doctoral degree. And I believe in the introduction you mentioned about one of the unique aspects of that is that all of these individuals are encouraged to return back home. Now, a lot of people have talked about here in the United States is that when we have a science gap, engineering gap, and so forth, we ought to get people from other countries who we've educated here and so forth, and not send them back home, but rather use them here and so forth and all that. So this program, in some respects, is kind of unique. Could you at least share with the audience a little bit about the benefits that have come out of encouraging these individuals to go back home in a broad sense, not only for the United States, but for the world itself?
Actually, I planted Ralph. Ralph has worked over many years with me on this program. Since we got funding for it in 1988, we've probably trained on the order of about 100 PhD and MS students and more postdoctoral students. And I told the students that are currently in the program that if they can get their gluteus maximus here, I was going to flunk them all. We require them to do two things. They come here, we pay everything for them. They complete their coursework here, and we don't give them any advantage. They have to compete with the American students. We then require them to do their dissertation research back in their home country, because I think doing dissertation research in this country is irrelevant to what's going on back in their home country. And we require them to sign a little thing that says, if you jump ship, you got to pay Dr. Deedles $250,000 because that's what it costs to educate you. These guys go back, and there are a lot of benefits. A couple of them have become ministers of health. Most of the directors of the HIV/AIDS programs in Asia, Southeast Asia, are in fact graduates of this program, including the director of the AIDS program in Beijing for China. So it's exciting because you develop a very personal relationship with your students. One of my daughter-in-laws once said, I'll get in trouble for this, that I love my students more than I love my son. I was very tempted to say that's because they treat me better, but I didn't. But you establish a very warm relationship with these students. Now, that has benefits for UCLA, because UCLA now has this network of researchers all over China, Southeast Asia, and India. And many of the faculty have established research programs and research projects by making contact with these graduates, because they tend to develop a deep affection for UCLA and a tremendous loyalty. So this facilitates the opportunities for faculty and students as well. A number of my American students have contacted some of the graduates and developed research projects. So it's been a very exciting program. I think it really has had some very significant benefits, and I can't underestimate how rewarding it is. But I do love my son.
Okay, we have time for one more question.
My son has
I
one.
think this gentleman right up
my
here
son.
probably deserves a closing remark.
You're not allowed to ask your father questions.
All right. Well, I wanted to say I accept pretty much all the truths that you've talked about today, but I do have contention about one assertion that you've made today. I do believe that Mimi Details has provided you with color-coordinated outfits, but I, having been in your presence almost 45 years, have to question whether you properly combine them throughout those years.
I will let you be the judge.
And I do want to thank you and say that your family's very proud of you today.
Good. Well, what a wonderful afternoon this was. I appreciated again how you shared the story of your science, the good, the bad, and the ugly, the sad, the exciting. And we're all more fortunate to be able to have shared in that with you today. But now is time to celebrate. So I'd like to invite all of you to go to the foyer of the Schoenberg and a little toast for Dr. Details. Thank you.
Video copies of this program are available for purchase from the UCLA Instructional Media Library. Call toll-free 1-877-958-2200. Additional information about the people, places, and ideas discussed in this program is available at our website, www.webcast.ucla.edu.